Hello, welcome to how to solve this very nice exponential equation. P to the power n plus 144 is equal to q squared. We need to find all possible values of n, p and q, where n, p and q are positive integers. So let's start by moving this 144 to the right side. P to the power n is equal to q squared. This plus 144 becomes negative 144 at right side. Next, p to the power n is equal to q squared minus this 144 can be written as 12 squared. Next, p to the power n is equal to, by using this algebraic identity, a squared minus b squared is equal to a plus b times a minus b. This q squared minus 12 squared can be written as q plus 12 times q minus 12. Now we have two factors at right side. So to make two factors at left side, we suppose that this n is equal to a plus b. Let n is equal to a plus b. And we replace this n with a plus b, then this equation will become p to the power a plus b is equal to q plus 12 times q minus 12. Now by using this power rule, a to the power m plus n is equal to a to the power m times a to the power n. This p to the power a plus b will become p to the power a times p to the power b is equal to q plus 12 times q minus 12. Now we write this p to the power a equal to this q to the power 12, and we write this p to the power b equal to this q minus 12. Like this, p to the power a is equal to q plus 12 and p to the power b is equal to q minus 12. We subtract these two equations. Because we are subtracting, this plus sign becomes negative, this plus becomes negative, and this negative sign becomes plus. And this p to the power a minus p to the power b, p to the power a minus p to the power b is equal to, this q will be cancelled out with this negative q, and this 12 plus 12, 24. Now from here we can factor out p to the power b. P to the power b times, in bracket left, p to the power a divided by p to the power b minus 1 is equal to 24. Next, p to the power b times, by using this power rule, a to the power m divided by a to the power n is equal to a to the power m minus n. This p to the power a over p to the power b will become p to the power a minus b minus this one is equal to 24. Now we have two factors at left side. This 24 can be factorized as 2 cubed times 3 and 2 squared times 6 and 2 to the power 1 times 12 and 3 to the power 1 times 8 and p to the power 0 times 24. So we have 5 cases. This is case 1, this is case 2, this is case 3, this is case 4 and this is case 5. First we solve this case 1. In this case we write this expression p to the power b times p to the power a minus b minus 1 is equal to this 2 cubed times 3. 2 cubed times 3. Now we write this p to the power b equal to this 2 cubed. P to the power b is equal to 2 cubed. We write this p to the power a minus b minus 1 equal to this 3. P to the power a minus b minus 1 is equal to 3. Now from this equation, if we compare base with the base and exponent with the exponent, then p will be equal to 2 and b will be equal to 3. Now in this equation we replace this p with this 2, we replace this b with this 3. Then this equation will become 2 to the power a minus 3 minus 1 is equal to 3. Now we move this negative 1 to the right side, then 2 to the power a minus 3 is equal to 3 plus 1, and 2 to the power a minus 3 is equal to 4, and 2 to the power a minus 3 is equal to, this 4 can be written as 2 squared. Now we have same base at both sides, so we can write this a minus 3 equal to this 2. So a minus 3 is equal to 2 and a is equal to 2 plus 3 and a is equal to 5. Now recall that we have supposed that n is equal to a plus b. We have supposed that n is equal to a plus b. So n will be equal to, value of a is 5 plus value of b is 3. So n is equal to 8. Now we have value of n 8 and value of p 2. Now to find the value of q, we use this equation. If we move this negative 12 to the left side, then this implies that q is equal to p to the power b plus 12. We use this equation to find the value of q. Q is equal to p to the power b plus 12. So q is equal to, value of p is 2 to the power value of b is 3 plus 12, and q is equal to 2 cubes is 8 and 8 plus 12 20. So the value of q is 20. From here we get the first pair of solutions, n comma p comma q is equal to, value of n is 8 comma value of p is 2 comma value of q is 20. Now we solve case 2. In case 2 we write this expression equal to this to the power 2 times 6. In case 2, this expression will be equal to 2 squared times 6. And we write this p to the power b equal to 2 squared. P to the power b is equal to 2 squared. And we write this expression p to the power a minus b minus 1 equal to 6. From this equation, p is equal to 2 and b is equal to 2. And from this equation, value of p is 2 to the power a minus value of b 2 minus 1 equal to 6. And we move this negative 1 to the right side, then 2 to the power a minus 2 is equal to 6 plus 1, 7. Now because this 7 cannot be written in the form, this solution can be found from this case. Now we solve case 3. In case 3, we write this expression equal to this 2 to the power 1 times 12. In case 3, we write this expression p to the power b times p to the power a minus b minus 1 equal to 2 to the power 1 times 12. And we write this p to the power b equal to 2 to the power 1, and we write this p to the power a minus b minus 1 equal to 12. From this equation, p is equal to 2 and b is equal to 1. We replace this p with this 2 to the power a minus, we replace this b with 1 minus this one is equal to 12. Now we move this negative 1 to the right side, then 2 to the power a minus 1 is equal to 12 plus 1, 13. And because 13 cannot be written in any power of 2, so no integer solution can be found from this case. Now we solve case 4. In case 4, we write this expression equal to 3 to the power 1 times 8. In case 4, we write this expression p to the power b times p to the power a minus b minus 1 equal to 3 to the power 1 times 8. And we write this p to the power b equal to this 3 to the power 1, and we write this p to the power a minus b minus 1 equal to this 8. Now from this equation, p is equal to 3 and b is equal to 1, and we replace this p with this 3 to the power a minus, we replace this b with this one is equal to 8. This negative 1 becomes plus 1 at right side. This 8 plus 1 is equal to 9, and this 9 can be written as 3 squared. So we compare base with the base, and we can write this a minus 1 equal to this 2. Like this, a minus 1 equal to 2. And from here, this implies that a is equal to 3. And because n is equal to a plus b, then n will be equal to 3 plus 1, and n will be equal to 4. Now we have value of p 3 and value of n 4. Now to find value of q, we use this equation q is equal to p to the power b plus 12. To find q, we use this equation q is equal to p to the power b plus 12. So q will be equal to, value of p is 3 to the power value of b is 1 plus 12, and q will be equal to 3 plus 12, 15. So from here we get another pair of solutions, n comma p comma q is equal to, value of n is 4 comma value of p is 3 comma value of q is 15. Now we solve case 5. In case 5, we write this expression equal to this p to the power 0 times 24. In case 5, we write this expression p to the power b times p to the power a minus b minus 1 equal to p to the power 0 times 24. We write this p to the power b equal to this p to the power 0, p to the power 0. We write this p to the power a minus b minus 1 equal to this 24. From this equation, b is equal to 0. Now we replace this b with this 0, then this equation will become p to the power a minus 0 minus 1 is equal to 24. And if we move this negative 1 to the right side, then p to the power a will be equal to 25. And this can be written as p to the power a is equal to 5 squared. So from this equation, p will be equal to 5 and a will be equal to 2. Now to find the value of n, we use this equation. N is equal to a plus b. So n will be equal to value of a is 2 plus value of b is 0. So n will be equal to 2. And to find the value of q, we use this equation. Q is equal to p to the power b plus 12. Q is equal to p to the power b plus 12. So q will be equal to value of p is 5, value of b is 0 plus 12, and 5 to the power 0 is 1, so 1 plus 12, 13. Value of q is 13. So we have value of q 13, value of n 2, and value of p 5. So from here we get another pair of solutions. N comma p comma q is equal to, the n is 2 comma p is 5 and q is 13. So these are the three solutions of this equation.